Hi, kids. All right, we're going to do a problem here. It says we have an electron. It's moving 500 meters per second to the right. It enters a magnetic field of 0.03 Teslas. That magnetic field is directed to the top of the page, and we want to find the force on the electron. I am a big fan of drawing a diagram, so let's draw a diagram of what's happening. So I have my little negative charge right here. It is moving that way, 500 meters per second, and it goes into a magnetic field, and my magnetic field is directed like this. All right, so remember, force is a vector, so you need to find out how big it is and then also the direction. If we want to do the direction first, we have to use our second right-hand rule, so using our right hand here. Remember, your thumb points in the direction of the current, or remember, current is conventional current, which is the direction that positive charge is moving. So if I have a negative charge moving to the right, my thumb has to point to the left, and then my fingers point in the direction of the magnetic field, so my fingers are pointing to the top of the page, so that my palm now is pointing into the page. So we know that the force that's going to be acting, the force is going to be directed into the page. So the force is going to be an X. But now I need to figure out how big that force actually is. To find how big that force actually is, we're going to use the formula, which is F equals qvB sine theta, okay, where size of the charge, the velocity, magnetic field strength, angle between V and B. So if I do this, I get F equals Q. Remember, my Q is the charge of an electron, which we know is negative 1.6 times 10 to the minus 19th. Really, guys, negative's not that important because we're trying to find direction. So if you want to put it, fine. If you don't want to put it, that's fine. But at the end, the important thing is the direction. So I'm not going to worry about it. 1.6 times 10 to the minus 19th times my V, which is 500 meters per second, times my B, which is 0.03, and then sine of 90, because the angle between the two, 90 degrees, which is just going to be 1. Okay? So now I got to do the math here. Let me grab my lovely calculator, do some math. 1.6 e minus 19 times 500 times 0.03, and you get 2.4 times 10 to the minus 18th. And the units are newtons, and remember, we said it is directed into the page for there. So that is a really small force, but remember, we're talking about an electron, a teeny, teeny, tiny thing with a teeny, teeny, tiny mass, but that's our force. So there you go. Bye, kids.